Welcome back. In this video we're going to look at electromagnetic radiation and specifically how to find the wavelength of that electromagnetic radiation if you have the frequency, or the frequency if you have the wavelength. So let's get started. As an example, I put up a picture of a train. If you've ever counted train cars as they passed and to see how long a train was, if you knew exactly how long those train cars were, and you knew how many of them passed in a certain amount of time, you could easily figure out how fast the train was going. If you didn't know the size of them, but simply knew that they were all the same size and that they passed in a certain amount of time, at least you could figure out the frequency. So as a formula, we see that nu, which is the Greek letter nu, kind of looks like a fancy V, is what we're going to use for frequency, and it's just the number that passes in a certain amount of time. Normally we do it in a second. So how many somethings pass by you in a second? How many times does your tire go around in a second? How many times does your motor go around in a second, or your fan go around in a second? That's normally its frequency. If something is oscillating like a pendulum of a clock, or something that's vibrating back and forth, you also measure that in frequency. There's a certain, like if your voice is at a certain pitch, that's the frequency of your voice. And so it is going to be measured in cycles, like how many train cars pass, or how many times the tire goes around per second, and that will be its frequency. Now, cycles, you have to be careful, is not a mathematical unit. You do not use cycles to actually say something with. It's only something going around. It's not something that's measurable. So for that reason, the units for frequency is just inverse seconds. Anything divided by 1 second, or a second to the -1 power. So if you knew how many cars passed in 1 second, so that's its frequency, and you knew how fast that the train was going, you could find out how long each car was. And that is analogous to the wavelength. If I know the speed of electromagnetic radiation, and I know the frequency of that magnetic radiation, then I could find out how long the crests of each of those waves are. So let's look at the formula here. This is the first formula that we're studying in this chapter, and it's equal to C equals lambda nu. And C is an English letter. Lambda and nu are both Greek letters. And what they're standing for here is the speed of light. C is going to be the speed of light, which we're going to see is 3 × 10⁸ meters per second. Lambda is the wavelengths. That's the distance between the top of one wave and the top of the next oncoming wave, or the bottom of one wave and the bottom of the next wave. That's the wavelength. And then the frequency is what we've looked before, how fast it's going, how many cycles per second that there are. So if we know that 3 × 10⁸ is the speed of light, and that is a constant anywhere in the universe. Speed of light is 3 × 10⁸ meters per second. So if I know the speed and I know a frequency, I can find a wavelength. So let's look at an example. Electromagnetic radiation with a wavelength of 725 nanometers is red. What's its frequency? So you're going to start with the formula of I have the frequency, is what I'm trying to find. So I have the speed of light, and I'm going to divide by the wavelength that was given. So first of all, I need to convert the nanometers into meters, because speed of light is in meters per second. So 1 × 10⁹ divided into it is 7 × 10⁻11, and then so I just put it together. The frequency is speed of light over wavelength, and I end up with 4.14 × 10⁻14. So I hope this helps. Look at it as much as you need, and thank you.